Hello, how are you? My name is Anna Bensel. Welcome back to my channel. We are going through as many LeetCode problems as we physically can in a year, and we are on question number 95, which is unique binary search trees 2. Now, let's go ahead, roll up our sleeves, and get right into the solution, which is going to be in Python today, by the way. And yeah, so given an integer n, return all the structurally unique binary search trees, which has exactly n nodes of unique values from 1 to n. Return the answer in any order. Sorry, y'all. I'm still a little thirsty. So, okay. This is pretty cut and dry. They give us these examples here. So input is n. This is the output: 1 null, 2 null, 3, 1 null, 3 2, 2 1 3, 3 1 null null 2, 3 2 null 1. Okay, so we have all of these in different configurations, and then the example 2 is just with 1, and then it looks like this is our only constraints. So, okay, so given an integer n, return all these structurally unique binary search trees, which has exactly n nodes of unique values from 0 to n, or from 1 to n. From 1 to n, I misspoke. So n in this case, 1 to 3, we have 1, 2, 3 in a variety of different ways. So let's see. We should define a function called generate trees, like outside of this generate trees function that we already have. So we can take two parameters and get that range of values, because I think that'll be the only way this can work. And I think I'm going to take a recursive approach to this. I don't see why I would need to do another one. So let's say def generate trees start end. So we're going to say right off the bat, if start is greater than end, then we're just going to return none. That's going to be our base case for this. Then let's initialize for all trees. We'll put that in there to store what we collect. Yeah, so this will just return this empty tree. Then I need to break this down into root values. So the root values, and then we need to break it into the left and right trees. So, we're going to say for root val in range from the start to the end, incremented. Then we're going to say left trees equals, and then right trees equal, we're going to say generate trees start root val and decrement. But for the right, we're going to say, I'm just going to copy this and we're going to change this in the inside of this here. So we're going to say, we're going to say root val plus 1 and end. So from there, for left in, I don't like the sound I just heard. That's either my cat or someone breaking in. I guess you guys will see what happens. So we need to combine the root value with all combinations from here of the left and right subtrees to create the unique binary search trees. So I'm going to say for right in right trees, and this is how I'm going to do it. I'm going to say the root, and then we're going to say root left. We're also going to say root right, and then we are going to do all trees and append that result with the root. So for the root, we do need a tree node, which also has the root value. We also need this for the left. We need this for the right. So when we go into the return, we're going to have this return all trees. Okay. So I have, if start is greater than end, it returns the list with a single element containing none. But I need if n is equal to 0 somewhere. Can I just... Nah, I'll just do it right here. If n is equal to 0, then we return this. That way we can return generate trees, generate trees 1n. Okay, so that feels pretty good. I think it kind of takes into account for everything. This would have the BTS's ranges. It seems pretty efficient. I'm just looking at how I structured this, and it coincides with how this example runs. Maybe I should have put this up. You know what? I'm just gonna put it up here. Nah, I'm not gonna mess with the flow right now. Okay, so let's read through this. Given an integer n, return all these structurally unique binary search trees, which has exactly n nodes of unique values from 1 to n. Return the answer in any order. I mean, they didn't give us anything indicating that this needed to be in. Anyway, let's just go ahead and run it. I'm overthinking. I've already done 3 questions or 4 questions or whatever today. Runtime error. It's because I put a period there. Sorry, gosh. Generate trees. Oh my god, I did it twice. What? You guys, why do I have spelling errors today? Is it because I haven't had caffeine? Good lord. Okay, so this is running well. I don't, now this makes me nervous that I got something else wrong in here, like computation, but I don't think I did. Let's go ahead and submit this. Yeah, I feel confident. We can go ahead and submit that bad boy. Yabba-ba-boy. What is this submission? Ooh, runtime did really good. Oh, thank goodness, you guys. I have been struggling today with not getting over 50%, and this one did for both. Maybe I just needed the warm-up. That's what I'm going to tell myself. I needed to get my brain started. I'm going to have some caffeine. I have a super zen candle that's just making me want to sing Kumbaya. It's great. Cool. Okay, so I'm going to leave this in the GitHub repo that I have, which is linked down in the video description down below. You guys, please feel free to fork it and clone it. Make it better, make it worse. Have some fun. Learn something new. thank you all so much for watching. Seriously, I really appreciate it. And any feedback that you have, literally for anything, it doesn't have to be my code. It could literally be the clothes I wear. I don't really care. Please feel free to drop it in the comment section down below. I'm always trying to get better, especially when I'm trying to explain things. So if I did not explain this well, because sometimes I just get caught in the thought, which is something I am really trying to work on. That's part of the reason I even started this, as I've mentioned before. But if you're new here, I just want to improve on my explanation. I want to improve on my quality of code. I want to improve on the time it takes to think of how I should execute it, just to kind of keep myself ahead of the game. So again, thank you all so much for watching, and I will see you in the next video. Goodbye.